Hello guys, how are you? This is Daniel Pinheiro from danielpm1982.com. So now let's create our domain classes. In our classes we'll have a very similar structure compared to the tables of the relational model. So let's start creating the client class. And for that, you click the right button, new Java class, client as the name. Here you select if you want a class or an interface, an enumeration, an annotation. But in our case, we're creating a class client, or we could create interfaces for all our domain classes, but as it's a simple project, I will only create the classes directly. So new Java class, client class, click twice. Okay, here is our client class, and first let's create the fields. So here are the fields for our client domain class. You have a long ID for modulating the primary key data. We have a string name, a string email, a string street, an int street number, a string city, a string country, a local date, birth date, and a string info. And you see that none of these types will be the type of the corresponding data at the tables. So both the variable names here at the programming side as well as the data types for these fields will be different from the data types and field names at the table. So when we start creating our DAOs or our repository classes, I'll show you how and where at the program we can convert these data from the data types used at our domain classes to the data types used at our relational model tables. But for our client model class, after creating the fields, we then create the constructors for this class, and we'll create both an empty constructor as a full constructor, taking all these fields as parameters for receiving the respective arguments in order to create a full client class when we instantiate. But we can also use the empty constructor for instantiating an empty client and then set these values later after instantiating. So now let's create these two constructors, and for that you can use the generate or alt insert shortcut so that IntelliJ will automate that creation for you, which is pretty nice. So generate constructor. First let's create the empty one. So instead of selecting anything here, you just select none, and here it is, the empty constructor for our client model class. And now let's create the other constructor, taking all these fields as parameters. Now let's use the alt insert. In the same way, we select constructor. Now we select all the fields and we press OK. Let me maximize here. So here is the full constructor that will take all these fields as parameter. So after creating the fields and now the constructors, let's create the assessor method or the getters and setters. So following the same shortcut or process, you click the right button and select generate, or you press Alt Insert. But now instead of constructor, we set getter and setter. And again, you can choose any combination of the fields, but in our case we want to create getters and setters for all fields, so let's select all of them and press OK. So here it is. Let me just delete these useless spaces. Okay, so here we have all the getters and setters for all our fields, and the only exception of field that we won't need the set method is for the ID, because it will be the primary key, and the primary key generally is generated and managed by the database. But as in this case we are not using databases yet, I'll leave the set ID as well as the ID parameter at the constructor, but later we can delete the ID setting both from the constructor. We won't create or set an ID argument to this parameter at the constructor, because it will be automatically created by the database. And also we won't have to set, and actually we shouldn't turn available this set ID for the primary key for safety issues, but for now I'll keep that. So we've created the fields, we've created the constructors, and now we've also created all the getters and setters for our fields. And now let's create or override the toString method. We can simply start type 2 and a suggestion for toString method will appear, or we can also click the right button and generate the overriding of the toString that we received from the object class. And here we select which fields we want to add to the toString. In our case we want all the fields, so we keep everyone selected and press OK. And here we have the toString method, so that when we print an instance of this client class, instead of the instance hash code, we will print actually the toString content from this method. So we will print actually this when we print, for example, through the system out print line, any instance from this client class. So for all model classes you have to override this toString method if you want to print any formatted content when printing an instance of that class. And now the only two methods we have to implement are the equals and hash code. Here we have more than one template for creating them. I'll select this Java 7 Plus template, and you just click next and select the fields you want to include as members of the equals method, then as members for the hash code method. Then you select all the non-null fields, and I'll select all the not optional ones. As you remember, the info field at our relational model table client is optional, so it can be null, and all others will be non-null fields. And then you click finish. So here are the equals method and the hashcode method, and in case you don't know about them, both are used basically when compared different instances from one same class, for example different clients, in order to check if they are equal or not. So the JVM will consider not only the fields data but also the equals and hashcode, as here we've set, to tell us if those two compared instances are the same instance or not, if they are different instances. And there are a lot of scenarios in which we would have to make such comparison. And that's it for the client entity. That's what we had to do. The fields, the constructors, the assessor method, the toString method, and the equals and hashcode method. And basically that's all we have to do for also the other domain classes. So now I'll create the order class, which will manage the data from our relational order table. Now I'll create the fields. So here are all the fields from the order table at the database that we are modeling to the order domain class. And also here we are changing the data types compared to the relational schema, and also we are changing the variable names. We don't have to use the same exactly names that we used at the tables. So the fields are the long ID, the order ID that I'm simply calling ID, the time as a local time, and the date as a local date. And both the local time and local date are types that are not available at the database because they are from the java.time package. So as I said with the last class, when we have to interchange the data between the program and the database, we have to change also the type of the data as well before persisting the data at the database, and also when retrieving the data back to the program application. And we also have the string info as well as the client ID, which, as you remember, is the foreign key for the client table. And actually we don't model foreign keys as this. Instead of creating a field for only the long value of the foreign key, we use instead, I'll just type it here below and then I'll exclude this line here because we want to use the field like that. We use a field using the object as such. So instead of having a field only for the long data of the foreign key, we use instead the object itself or the class corresponding to that foreign key. In our case, the client object and a variable that will point to the client and to all client attributes and methods from the other object or from the other class. So this we don't use. Instead, we will use a field of type client and with the variable name or field name as client. And that's basically to facilitate when we have to access a client from the other object. If we simply stored here a field for a long value for a foreign key, we would still have to search for the client instance that would match this foreign key, which would be the primary key at the client. So we simply use the whole object inside this other object that will refer to it. So the other class will refer to the client class through this instance variable or field of type client. Okay, now we follow the same process and also create the constructors. Initially an empty one, then a full constructor with all these fields as parameters, selecting all the fields here. Now we create the accessor methods, getters and setters. And also, as I said, at the client class, at the other also, we will temporarily turn available the manual setting of the IDE, both at the constructor as at the set method. But when we create the database and start using our DBMS to auto-generate that, we will delete this option because all the IDE creation will be done by the database. But for now, we'll leave it so we can set it in this project example. And now that we have created the fields, the constructors, and the accessor methods, let's create the toString. And for that, instead of generating through this shortcut here, I'll only type to and accept the suggestion to override the toString, selecting all the fields. That's it. And lastly, let's generate the equals. We can also start typing and accept the suggestion. Next. For the equals, I'll set all the fields as well as for the hash code. And the non-null values will be all of them except the info, because each other must have at least one client, so the client field also can't be null. And the only null field that we can leave without checking here is also the info field, which is optional. So finish. And here we have the equals and the hash code. And with this, we finish the creation of the other model class. And now we have two more classes to create here at the Java application side. And the next is the other item. So let's create the other item entity class or model class. If you take a look here at the relational schema, the other item is the weak entity that we converted into a table. In this table we'll have, instead of one primary key or one ID, it's gonna have two IDs, one from the order item itself, which derives from the partial key, and the other as a foreign key for the order table. And we should have both references for each order item instance in order to it to be unique, because only the order item ID wouldn't guarantee the uniqueness of every instance of order item, because we could have, for example, an order item ID number 5, the same order item ID number 5 for multiple orders. So we can only guarantee the uniqueness of the instance if we have the order item ID, for example 5, combined together with the order ID, which is a foreign key for order. And then for that order we can guarantee that there will only be a 5 value for the order item ID, but not for every order. So also in our order item class, we gotta modulate in a way that will both set an order item ID as a reference to the order object that we are referring from this order item. So we'll create an ID field for the order item ID, and for the foreign key also we won't use the foreign key value, we will use an object reference to the order object. So instead of order ID, we'll simply use an order type instance variable or field. But we gotta use both fields in order to instantiate our order item and guarantee the uniqueness as well as the relationship to the order. So let's create the fields. And here are the two fields that represent the corresponding primary key of the order item table. And you just gotta remember that when, for example, you have a data structure with many order items, if you want to filter or to compare any order item instance, you gotta consider both the order item ID as well as the order instance to which it refers, so that you can guarantee the uniqueness of that instance. If you just compare through the order item ID, you may end up having more than one instance from order item class with the same order item ID, but not more than one instance with both the order item ID combined with an instance to the order class. So let's create the other fields. Okay, so these are all the fields that we're gonna need for our order item model class. The long order item ID, the order type order, the int quantity. For the discount and price, we will use the Java type big decimal, which is advisable when you're dealing with money values. So both for price as for discount, we're gonna use this big decimal type, which is also different from the types that we used at the order item table at the database, and we'll have to convert that to a proper database type And we also have the info as a string. And lastly, we have a reference to product, which is a class that we have not yet implemented. That's why we can't import it now. But as soon as we implement it, this red arrow will disappear and we'll start referring from this order item to the product class using this product variable or field here. So the same that happened with the order here. We also do not use the foreign key value. We use an object reference to the other class. So here at the product, instead of the foreign key to product, we use a product type object reference. So now we can create the constructors. The accessor methods. And also here we won't need and shouldn't have the manual setting of the ID either at the constructor or at the set ID method here. But for now we will leave them as such. Then we implement the toString for all the fields. And then the equals and hash code, selecting all the fields for equals, all the fields for hash code, and as non-null fields we will select all the fields except the info1, because any other item instance must have an order reference. Actually, the discount I should have put as optional at the database, so I'll treat it as mandatory here as well as I did at the database. You can simply put a 0 as the discount or not leaving it as null. The price, every item must have a price. The info is optional, and the product reference here is also mandatory because every other item instance must refer to a product. So click finish, and this is our equals and hash code methods in case we have to compare any two instances of this same class to see if they both are equal or different instances. And finally, the last class we gotta create also for correcting this error message here from other item is the product class. So as you can see, as soon as you create the product class, the error from other item disappears. It already detects the product from the same package domain and recognize the types here, product, wherever it's used at our other item class. So for the product class, let's create the fields. So these are all the fields from the product object. This object, the respective table has a primary key, which is the ID here. But at the table, as you remember, there's no reference from product to any other table, so we only have the fields for the product itself. We don't have any reference to any other object or any foreign key to be modulated here. So these are all the fields. And now let's create the constructors. The accessor methods. The toString. And the equals and hash code. And as non-null fields, we only do not select the info as we did with the other classes. Okay, so here we have all the fields, the constructors, the accessor methods, the toString, and the equals and hash codes for the product domain model class. So, and another thing that I like to explain to you in advance right now is that if you see here, we don't have any reference from product to other item class, so we can't directly see which other items is this product instance being included to, because we don't have any reference from product to the other item. We have the inverse relation. We have at the other item we have a reference to the included product, but we don't have from the product to the other item. And although we can take a product and try to filter all the other items we have for searching for a product ID, it would be much easier if we had, for example, in this case, that we have one product for many other items from different orders, from different or from the same client. We could have here at the Java programming side, differently from the database side, we could have here a list of other items, for example, as such, and it would be very much easier to get the list of other items which an eventual product instance would refer to. So for every product instance, we could simply get the other item list and see more directly to which other items that product instance refers. And actually we'll modulate that when we start using JPA, because here if we did that, we would have much trouble in maintaining our application, because for every other item that I added, I would have to alter the other item list of the product instances, and it would end up generating inconsistencies. So in our case here, that we are not using JPA, it would be better that we didn't have this field, and when we want to see which other items each product instance is related to, we use the inverse relation to get that and filter within the other items instances the ones with the product reference containing this product ID field. But for example, when we use JPA JPA has an annotation that we can use for doing exactly this in a one-to-many relation. Instead of we manage the data for this relation from the one side to the many side, we simply use a mapped by annotation, and the JPA itself, not persisting that on the table but doing that programmatically, it takes the inverse relation from the, for example here, from the order item to the product, and it filters or selects the other items that would refer to product, and it automatically manages the, for example here, the order item list itself without we have to bother with that. So simply understand that for now we are not using this order item list, but as soon as we start using JPA, we'll also use this field to have a more direct access to the order items which each product instance refers to. But despite all that, we can search at any data structure containing order items for the order items that would have this product instance and have both the order items as the product that would match that relation, even without that more direct order item list for now. So having said that, if you didn't understand that, just wait until we start using JPA and I'll explain it again, because it's actually pretty hard to explain without showing the code. So I just wanted to take your attention to that, but I'll explain much better when we start using JPA. So we're finished creating all the domain classes, and as we don't have a database yet, and also any Java class as a GEO or a repository for exchanging data between the Java application model classes and the database tables. For testing these four entity classes, we will simply go to the main method from the main class and simulate the population of data for those classes and then print out their content. So we create some clients, some order items, and some products. We'll relate them through the references we have on each class. Then we'll add them to some data structures, and later we'll print out that structure's content at our console. So let's start by creating some clients. So here we have the first client, client C1, new client. In here we pass all the arguments for the full constructor that we've created for this client class. And as you see, when you start putting the arguments, IntelliJ already shows the corresponding parameters for you, but have in mind that these parameter names here are only enabling visualization. It's not part of the code. So here, of course, you won't have the ID, the name, the email, the street, etc. as arguments. You will only have this argument that I've typed. This first one, a long value for the ID. This other one, a string name for the name parameter. This other argument, the email for the email parameter, and so on. The street number in each value, the city name, the country name. Here for the birth date, you gotta pass as argument a local date instance. And for getting that instance, you do not instantiate the local date. You use the static method of the local date class, for example, local date of, and then you pass the arguments for the of method. For example, for the year parameter, you pass 1980. For the month parameter, you pass the argument 5. And for the day of month parameter, you pass the 1 argument value, and then you get in return an instance of a local date based on those 3 arguments you've passed through the static method from that local date class. So that's how we get a date or a time. Basically, all objects from the time API have static methods for returning an instance, so that you do not have to instantiate the object directly. And lastly, the only optional parameter, which is the info parameter, I'll just set as null here, so that you can see that it accepts a null value for that without returning any error message. And then I'll create some more clients with different argument values. Okay, so now we have 3 client instances, and let me now create 3 products. Okay, these are our 3 product sample instances. So for the product, we gotta pass as arguments for now the ID, the name of the product, the description of the product, as well as optionally the info. We could set it as null here, for example, and just take into account here, as I have already explained, that we're setting manually the ID for all our domain classes instances. For example, here for the client, we're setting the ID as 1, 2, and 3. For the product as 1, 2, and 3 also. But in practice, when we are using our database, this ID will be automatically generated by the database for each table, and we won't have this ID setting for the constructor, neither for the set ID method at the accessor method. So we are just temporarily setting this ID manually, but later on we'll leave that to the database management system to set automatically. Okay, so now let's simulate the creation of some orders and other items for our clients regarding our just created product. Okay, so at our main, we've created 3 client instances, 3 product instances. We also created 3 order instances, 1 order for each client. And also we've created some order items, 3 order items for the order from the client 1, 2 order items for the order of the client 2, and 1 single order item for the order of client 3. Of course, you could have any number of order items for each order, and you also could have any number of orders for each client. For example, if client 1 wanted to make another order, you would just instantiate another order for that client 1. And if you wanted to add, for example, another order item for the order of client 3, you would just instantiate another, as we did here with the order items for the client 1 and for the client 2. So if you pay attention here, the order item will refer to all other instances, types, or instances, objects. For example, the order item will refer to a certain order, and that certain order will refer to a certain client, and also the same order item will refer to a product. So for showing all the data for each order item and for all the order products and clients involved for that order item, we're gonna create an array list and add all these order items, and later we'll print all the order items from inside that data structure. But a last thing that I'd like to show you here regarding these instances instantiating is that the same way that we have static methods for getting instances from all Java time objects, for example local time and local date, for getting an instance for the price and for the discount, we also gotta use the static method value of from the big decimal class. So in case you never used big decimal, for you to get an instance of it, you gotta use static method, and through that static method the class will have a constructor or a factory for giving you back instances of big decimals. In our case here, an instance with the value 50, an instance with the value 10, and so on. So now let's create our array list and add all the other items, and finally print them out to our console. Okay, so here we have the list with all these few other items that we've created, and from these other items we can get the order, the product, and the client to which it refers. And for printing the items from all Java data structures, you can simply use streams. So you call the instance of that data structure, and if you want to make any operation on the items, you call the stream to get an stream of other item instances. But if you simply wanna print out the items, you call for each. You can use this reference method system.out : print line. So this will print all the other item instances that we've created over here, and through the toString method of that other item objects, it will also be printed the order, and through the toString of the order it will be printed the client, and also through the toString of the other item it will be printed the product as well. So let's test our class, and for that you can go to the project structure here on the left and press the right button, the class that you want to run, and select run main or run and the name of the class you want to run. Or you can select here what class you want to run and press here on this run and the name of the class. Or even if you had pressed here over the project and ran this arrow button here, it would also run the main. Or you could also press here on this arrow, which is the same one from here, and it will run this main class or this main method. It would have the same effect if you press here or here. So let's run it. Okay, it ran successfully. In here we have the hello world, which is from this line of command here, and then right below we have the printing of all other items we've created, and through the toString of the other item we have the printing of all the data inside or related to that other item. Now let's suppose you wanted to filter only the other items from the orders from client 1 instead of printing the whole list. We could simply use the same structure and use streaming to filter that. For example, instead of for each, we would have to use the stream static method for getting a stream of other item type with all the list items. Then we would use the filter operation, which receives as argument a lambda telling what to filter. So here, for printing all the other items only for the client 1, we would use the other item list instance variable dot stream method dot the filter operation over that stream of other items, and for the filter operation we would use a predicate lambda. So for every item on this stream, and in this case the item is another item type, so for every other item on this list we are filtering or processing this operation of filter to select the other item order, and with this we get the order for each one of the other items. Then from the order we get the client, from the client we get the ID of the client or the client ID, and we set as the filtering condition the one value for that client ID. So from the other item we get the order, then we get the client, then we get the client ID, and then we set that we only accept those IDs which match the one value here, which is the value for client 1 ID, the same as here. And we have not only to filter but to print, of course. So we gotta put here at the end, after filtering those items within that streaming, we still have a streaming here at the end with only those filtered items of that list that match this condition or this predicate. And now for each we'll print them out using the same reference method that we used on the latest example. So first we have a list. We transform that list into a streaming of other items. Then we filter with this predicate lambda the items that are related to client 1. And lastly, we show all the remaining items, the items that matched this predicate, we show them at the console. So now let's test it again. And here we have all three other items related to client 1. All three from client 1. Okay, we could adopt a similar approach to filtering products, or to filtering a certain order, or for filtering any object related to other items. And as other item relates to all other model objects that we've modeled from any other item data structure, as here, we can filter and select based on whatever predicate we want, and select based on a certain order item primary key, or an order primary key, or a product primary key, or a client primary key. So that's why I said that, at least for now, we don't need to have a more direct list at the one side of the entities. For example, we don't need on client class to have a list of the others, and we also don't have to have at the product a list of other items, because we can simply programmatically select that from our other item, as we did here using streaming filter. It would give us much more work to do if we had to maintain all our instances, and every time we added a value to the inside relation object, we would have also to update the other object type. So every time we altered the order, for example, we would have to alter the eventual list of orders that we used at client, and every time we altered the order item, we would have to alter also the list of other items inside the respective related product instances. So that's why I chose not here to use lists on the one side of the relation objects. We will do that when we start using JPA, because with JPA we can automatically use the mapped by annotation to get that freely of any effort cost from the JPA framework, which is pretty nice. So when we start using JPA, we can simply add the lists of orders to client and the lists of other items to products, and the framework will automatically manage and update all the data at that one side object based only on the data on the other side at the end side, which is the data we have here at the other client reference and at the other item product reference. So we would manage only these references, and the JPA framework, if we use that mapped by annotation, it would automatically manage those lists that we're gonna add to client and to product classes when we start using that JPA feature. But for now, we won't complicate things, even because, as I've shown you, we can use streaming to select whatever relation we want, starting from the other item instance. But of course, it will give us much less work when we add those lists to client, the list of orders for each client and the lists of other items to each product. But as long as we don't have to manage or to maintain those lists each time we alter the inside domain objects. So for this project, that's it. Now the only thing that I'd like to show you, still regarding the user interface from IntelliJ, for accessing the sections of this user interface. As you may have already realized, we simply open up and collapse by clicking on the border respective sections. For example, the project we open and close by just clicking here. The structure as well, favorites, the to-do, the run, and other sections that we are still to use as the database, as the VCS section when we start using Git, and as the Maven section that will appear here when we start using Maven for our examples. And finally, if you remember that we altered the custom VM options, we can also alter it again by clicking here on the help option of the main menu and click here again, edit custom VM options, and here you will have the same file that we've altered. We've altered these 4 lines, setting as 8 GB the available memory for IntelliJ, setting as 480 MB the memory for the Java VM Jet, which is the cache for the VM, and we also changed the garbage collector algorithm for this other one. And by clicking here on help, edit custom VM options, you can change it again, any of these lines, and it will save again. And a way that you can see for yourself how much memory is IntelliJ using from the total 8 GB that we've reserved for it is by clicking here on the bottom right side. If you click here the right button, there will appear this only option here, memory indicator, and if you select that, you have here the amount of memory that IntelliJ is using, in this case almost 2 GB, and here on the final of the line you have the total available RAM that can be used for IntelliJ. So if you want to see how much memory IntelliJ is using from the total memory we reserved for the heap memory, you just click the right button and select memory indicator. And if you don't want that anymore, you just select it again and it disappears. That's it for this video, and there's still much more that will be seen on the next videos from this series about IntelliJ installation and testing. For example, in the next video I'm gonna show you how to synchronize with Git, how to create a Maven project, how to create real databases and synchronize that with our Java applications. And also on the next video I'm gonna show you how to use JDBC or Java Database Connectivity, which is an inbuilt Java SE API for database connection. So on the next video we're gonna create a real database for this schema that we have already defined, and we will synchronize the model classes that we've created on this application to that database we're gonna create by using JDBC without and with using the new role set for the JDBC version 4. And later on the next examples, we'll show you how to use JPA Hibernate for a very similar project. Actually, we'll simply evolve the project along all the examples. For example, now we've created a console application. Then on the next video, we're gonna create a Maven JDBC application for the same database schema. Later on the other video, we're gonna create a springboot web application for the same database schema and reusing the same model classes. And lastly, we'll create from that web application and web service application for that same database. So I hope you're liking, and see you on the next videos.